In this chapter, we will learn about some basic trigonometric identities. We will start with the identity sine square theta plus cos square theta is equal to 1. So this is one of the fundamental trigonometric identity that you need to remember. So sine square theta plus cos square theta is equal to 1. So let's try to see how we can prove this, right? So let's draw a right angle triangle and call this theta. Call the triangle A, B, C with a right angle at B. So let's call this side A, let's call this side B, and let's call side C in length, right? So from this triangle, we know that sine theta is equal to, remember our magic mantra, so kata, so kotoa. Sine theta is opposite by hypotenuse. So opposite side is A, hypotenuse is C, right? And then cos theta, we know that it's adjacent side by hypotenuse, so which is B by C. And we also know from Pythagoras theorem that a square plus b square is equal to c square. Square of the hypotenuse is equal to the sum of the squares of the sides, right? Okay, so having equipped with this information, now let's try to prove this theorem. We'll start with the LHS, which is sine square theta plus cos square theta. Now let's substitute the value of sine theta and cos theta in this. So we know that sine theta is a by c and it is square, so we'll say whole square, plus cos theta is b by c whole square. So if you simplify this, it's a square by c square plus b square by c square, which is equal to c square a square plus b square. But from Pythagoras theorem, we know that a square plus b square is equal to c square. So c square by c square cancels out, which is 1, which is equal to RHS. So LHS is equal to RHS. So sine square theta plus cos square theta is equal to 1. So in this lesson, we will learn about the second trigonometric identity. 1 plus tan square theta is equal to secant square theta. We can prove this in two ways. So first way I can show you by drawing a right angle triangle, which is ABC. We call the sides A, B and C, and we know from Pythagoras theorem a square plus b square is equal to c square. So let's call this angle theta. So we know that tan theta is from our mantra, so ka toa, that tan theta is opposite by adjacent, so a by b. So and secant theta is 1 by cos theta, right? So 1 by cos theta, and we know cos theta is adjacent by hypotenuse, so it is 1 by b by c, which is equal to c by b. So now substituting these values, we know that on the LHS is 1 plus tan theta, which is a by b whole square, which is equal to 1 plus a square by b square, right, which is equal to b square plus a square by b square, which is equal to, from Pythagoras theorem, a square plus b square is equal to c square, which is c square by b square, which is nothing but from our secant theta, what we have is secant theta is c by b, which is secant theta square, which is nothing but our RHS. So we have hence proved LHS is equal to RHS. Another way to prove the same identity is, we know tan theta is sin theta by cos theta. So sin theta by cos theta, which is square, which is nothing but 1 plus sin square theta by cos square theta, which is nothing but cos square theta plus sin square theta by cos square theta. We know from the previous identity that sin square theta plus cos square theta is equal to 1. So cos square theta plus sin square theta is 1, which is by 1 by cos square theta, which is nothing but secant square theta. So LHS is equal to RHS. The next trigonometric identity that we are going to solve is 1 plus cot square theta is equal to cosecant square theta. So again, there are two ways we can solve this. One is a straightforward way of using the previous identities that we have derived. We know from our previous identity that 1 plus tan square theta is equal to secant square theta, and we also know sin square theta plus cos square theta is equal to 1. So let's call this 1 and let's call this 2, and let's see if we can prove this identity that we have written here. So we know that cot theta is 1 by tan theta, so it's 1 by tan square theta. So let's start with the LHS. So taking LCM, it's like tan square theta plus 1 by tan square theta, and we know from 1 that 1 plus tan square theta is secant square theta by tan square theta. So now let's convert everything into sine and cos. So secant square theta we know is 1 by cos theta. So it is 1 by cos square theta, and we know that tan theta is sine theta by cos theta. So sine square theta by cos square theta. So if you do this, it's 1 by cos square theta times cos square theta into sine square theta. But cos square theta cancels out, and we have 1 by sine square theta, which is nothing but cosecant square theta, which is nothing but our RHS. So LHS is RHS. We have proved that this 1 plus cot square theta is equal to cosecant square theta.